In this question, we are given a diagram, which is a triangular prism, and we are required to find out the size of the angle between line BE and the plane ABCD. So I'm just going to add a line here to kind of show you what you're dealing with. Now, this is the angle that is required, this angle here. Just label it theta. So these guys want us to find the angle between um, this line BE and basically the base, which is ABCD. So the strategy for this, one thing you have to remember here is that if you consider this triangle ABD, this is a right angle triangle that's 90 degrees, and the length from here to here is 8. So you can be able to find that length there. And the height of this is 10, so that length is 10. So we have the height of this triangle that you're focusing on, but you can also be able to get this length here. So let me just call this x. So x here, which is basically that length, which is BD, or let's just call it BD to avoid any variables. So BD. So we can find BD using Pythagoras theorem. So by Pythagoras theorem, by Pythagoras theorem, we can say that BD will be equal to the square root of 8 squared plus 24 squared. Now we can basically work that out. So BD will be equal, if you just plug that in your calculator, that will be 25.3. So this is 25.3, that length BD. Now at this point you can consider this triangle here. So consider triangle BDE. Now if you look at that triangle, it looks something like this. Okay, so that's the angle, and we have uh, D here, B here, and E here. That's our theta. This is 25.3, and that's 90 degrees. This is 10. So we can use this idea to be able to work out the angle. So if you just use SOHCAHTOA, this is the opposite, that's the adjacent. So basically the tangent ratio is the one that applies. Yeah, so we can go ahead and say tan theta is equal to opposite 10 over 25.3. So theta will be equal to the inverse of tan of 10 over 25.3. So theta will be equal to 21.6 degrees. That's how you work out that question. Okay, next question, which is number 14. So number 14, here we have again a cuboid. Find the length of BC. So let's just call this x. Now, not something here that I want you to remember. Suppose we have a cuboid. Let's just do the random cuboid. Sketch a random cuboid here. So this is our cuboid, and I want to look at the relationship between these sides and this length here. Okay, so that diagonal that passes through this shape, let's just call this the which is from this corner to that corner, like this one, from here to here. So let's call this h. So the relationship between these three is four parameters is that uh, h squared is equal to s squared plus b squared plus c squared. So this is Pythagoras theorem in 3D. Yeah. So this is Pythagoras theorem in 3D. And we can apply that idea to work out this question. So basically, in our case, we can say that um, 6 squared plus 8 squared plus x squared is equals to 16 squared. And then we just solve for x. So basically, this is 100. So 100 plus x squared is equal to 256. So x squared will be equal to 156. X will be the square root of 156. So the value of x here will be 12.5 if you just use your calculator. And that's how you find the length BC. Okay, so this question continues here. Now, they want us to find the angle between FC and ABGF. So let's go back here. So between FC, which is that, and ABGF. So what we can do at this stage here is just draw another line here. So this, consider this to be just a diagonal of this face here. Now, the angle that's required is between FC and this face. So it's this angle here. I'm not sure if you can see it properly. So this angle here, that is the angle that we need to be looking for. So one of the things that you need to notice here is we have the value of x here, which is 12.5. Now, this is a right angle triangle. This one here, the right angle triangle. So if you consider triangle FBC, yeah. So here consider triangle FBC, which basically looks something like this. Then you have F, you have B, you have C, you have theta. So basically this is what I've done. I've kind of rotated this triangle. So F is right here, B is right there, and C there. So okay, and then I'll plug in the measurements. So the longest this side is 16, and that's 12.5 as you calculated. So if we just apply SOHCAHTOA here, SOHCAHTOA, this is the opposite, and that's the hypotenuse. So we apply sine. So we can say sine theta will be equal to 12.5 over 16. So theta will be arc sine 12.5 over 16, which implies that theta, and if you plug that in your calculator, that will be 51.4 degrees.